Hello lovelies, in this video the brilliant Mr. B is going to be looking at lots of questions using the product rule. Now this is for your A-level maths and the questions here are going to be worked through nice and calmly, slowly, so you can write them down, pause the video and maybe try the next one and see if you got it right or not. You don't have to worry about what anyone else is thinking, nobody's going to be sitting next to you judging you, and nobody at the front of the classroom is going to be rushing you on to the next topic. Once you've finished this video, over on my website there is a massive course with loads more questions to help you revise, including all of the worked solutions.
Differentiation, we've looked at differentiating individual terms and terms linked together by plus and minus signs. So, for example, our first term here, we would differentiate, we take the power, we take the coefficient, we multiply them together. 3 times 2 is 6. And then we kind of think, well, we've used up one of the powers to do that. So x to the power of 3 becomes x to the power of 2. And we can do that with negative 6x squared. 2 times negative 6 is negative 12, and reduce the power on the x. Then we look at the x squared. There's no coefficient at the front, just bring the power down. So that would give us 2x. And then we've got the negative 8x. So you think of differentiation as using up the powers, we've only got an x left. Then you're just going to have the negative 8 left over because we've got, a power 1 there. We don't normally write the 1. So 8 times 1 is the 8, but then we've used up the power, so the x is going to go away altogether. So that's all fine, but there's a difference with this question that makes this more complicated. The difference is we've got the brackets around the first two terms and the brackets around the second two terms. So what that means is we're multiplying these together. So we've got to think, well, how do we deal with these actually being multiplied? And is this, what I've written here, going to be the answer? Perhaps you might think, well, perhaps we have to multiply those together. So this is what we're going to look into. Now, there is a long way to get the answer, and the long way is just to expand the brackets and differentiate as normal. So we have 2x cubed minus 6x squared multiplied by x squared minus 8x. So we can think, well, we're going to do 2x cubed multiplied by x squared. That'll give us 2x power 5. 2x cubed multiplied by negative 8x, that'll give us negative 16x to the power of 4. We've got negative 6x squared multiplied by x squared, which will give us negative 6x to the power of 4. And negative 6x squared multiplied by negative 8x. That'll give us negative 48x cubed. Now you can collect together the middle terms. So all together, we've got 2x to the power of 5, take away 22x to the power of 4, take away 48x cubed. So if we differentiate that, 2 times 5 is 10, reduce the power. 4 times 22 is 88, and reduce the power. And then 48 times 3 is going to give us 144, and that's going to be x squared. So this is the answer we're trying to get with this. But we have to do this extra step. We had to expand the brackets first. Unfortunately, for this question, they're relatively easy brackets to expand, but they're not always going to be. So we want to try and find a more efficient method to do this. Now, going back to the previous answer, where we differentiate each of the terms individually, if you have a look at this, there really isn't going to be a way to get a power 4 answer by multiplying this together. So differentiating each term individually, as I did at the start, that actually isn't going to work for a question like this. So I'm going to rub that out because it's not right. It's a good exercise for practicing and reminding ourselves how to differentiate single terms, but it's not going to lead us to our answer efficiently. But we can see that one option is to expand the brackets first. Now, the efficient way of doing this is something called the chain rule. Now, I'll go through it in a little bit more detail on the next example. Essentially, what we're going to do is we're going to call the first bracket U, and we're going to call the second bracket V, and we have a little formula. If you're differentiating U multiplied by V, then that's going to become V multiplied by the differential of U, so a little dash tells us it's differential, plus U multiplied by the differential of V. So to do this, we're going to have a kind of a setup stage. So we're going to write down what U is. U is equal to 2x cubed, take away 6x squared, and underneath it, we're going to write what U dash is, differentiated version. So 3 times 2 is 6, reduce the power, 2 times 6 is 12, reduce the power. So we've got what U is. Now let's have a look at V. So V on its own is x squared minus 8x, and the differentiated version of V, bring down the 2, reduce the power, and we keep the 8. And it's actually the way we differentiated right at the start, actually. The difference is the kind of order. We're going to multiply these together to get our final answer. So we have a look at the formula. We want to do V multiplied by the differential of u. So that's going to give us x squared minus 8x multiplied by 6x squared minus 12x. Then we're going to add to that u. U is 2x cubed, take away 6x squared, and then multiply that by the differential of v, 2x minus 8. So let's expand the brackets. So starting with the first set, x squared multiplied by 6x squared is 6x to the power of 4. And x squared multiplied by negative 12x is negative 12x cubed. Then we have negative 8x multiplied by 6x squared. That's going to be negative 48x cubed. And negative 8x multiplied by negative 12x, that's going to give us a positive 96x squared. Moving on to the second set of brackets, we've got 2x cubed multiplied by 2x. That's going to give us 4x to the power of 4. Then 2x cubed multiplied by negative 8, that's going to give us negative 16x to the power of 3. Then we've got negative 6x squared multiplied by 2x equals negative 12x cubed. And then negative 6x squared multiplied by negative 8, that'll give us a positive 48x squared. So now we need to collect up the like terms. Let's look at the power of 4 terms first. We've got 6x to the power of 4, and we've got a positive 4x to the power of 4. So that's going to give us altogether 10x to the power of 4. Then we can look at the x cubed terms. We've got negative 12x cubed. So we keep track of this on the calculator as I go. We've got negative 48x cubed. Let's take away 28. We've got negative 16, take away 16. And we've got negative 12, so take away 12. Altogether, that's giving me negative 88. So we can write negative 88 x cubed. Then we can look at the squared terms. We've got a 96x squared and a 48x squared, and we are adding those together. So altogether, it'll give us a positive 144x squared. Now, comparing that to the answer we got by expanding the brackets first, because we've got the same answer. I do have a negative sign rather than a positive side, 144, but I realised that in negative times negative is positive, so these should have been positive numbers. Just a reminder that even for a teacher at A level, negative numbers can occasionally throw up a mistake, and it's a good place to look if you do make mistakes. So we've got exactly the same answer for both. So we have to think to ourselves, in this situation, which one is the best method? Expanding the brackets first and then differentiating, or differentiating and then using the product rule, expand the brackets second. Now, I think it's pretty clear that actually expanding the brackets first is the easier thing to do here. It's only 4 lines of working out, and one of those is repeating the question. Whereas using the product rule, we've written down the formula. We've got 2 lines of working out for differentiation, and then we've got 3 lines of working out for the brackets. So, it's kind of complicated here. Now, what you've got to be thinking with this is there's 2 reasons why to use a product rule. The first reason is that while you can expand the brackets first for the easy questions, with the medium and the hard questions, we're moving on to kind of more difficult kind of bits of algebra and trigonometry. And with those, you are not going to be able to expand brackets first in this way. So using the product rule with questions like this helps you practice the product rule, get good at the product rule, so then you can use it on more complicated questions that require you to use it, because you can't do it the other way. The other reason is an exam might want to test that you can use a product rule, but not give you a level of complexity that, using numbers like E or, sine and cos are going to bring. So they want you to prove the product rule on an easier question that maybe you could do a different way. So in that situation, just take the easier version as maybe a good way to check your answer. So you've proven you can use the product rule, and it's like, well, I'll do it this easier way to check my answer. So with the next 4 questions, bear with me with all of them. I know you can do them faster and simpler by expanding the brackets first, but it's all practice. We move on to the medium and the hard questions, which could be 10 questions where you can't use this easier method. So it's all practice. So moving on to the next question. First, let's look at the kind of official terminology for this. So it's the product rule, and you use it in differentiation when you find the product of 2 things. So it's when you've got multiplication involved, basically. The way you write it down officially is that d over dx uv is equal to v du by dx plus u dv by dx, just so you can recognize that, official terminology. Now, the kind of way that I like to write this, which I think this clarifies a little bit more what's going on, is that you take the first bracket to be u, you take the second bracket to be v, and what we are doing is we're taking u multiplied by v, and we are changing it. I'm not writing the equal sign here, because it's not strictly going to be equal. We're kind of changing it. So I'm going to use an arrow to show that. And what we're doing is we're going to have v multiplied by the differential of u added on to u multiplied by the differential of v. It's just using a dash to show differential rather than d over d. So now we can do our first step. We're going to substitute into the formula. So u is going to be 4x cubed, take away 8x squared. So u dash, differential of it, 3 times 4 is 12, reduce the power. 2 times negative 8 is negative 16, reduce the power. And now we've dealt with u. Be careful you write it, see my u, it's a little bit pointy there. Try and make it nice and round so you don't get confused with v. v is 2x cubed minus 5x. So v dash is equal to 2 times 2 is 4, reduce the power. And I'm going to keep the negative 5. So once you've written down what u and v are, and you've differentiated u and v, now we can look at the formula and combine them in the correct way using the product rule to work towards our answer. So we're going to have v multiplied by u dash first. So v is 2x squared minus 5x, and u dash is 12x squared minus 16x. Added onto that u, which is 4x cubed minus 8x squared, and we're multiplying that by v dash, which is 4x minus 5. So again, we've got kind of something that's quite long and complicated here, but we can expand brackets and we can collect like terms. So let's do that. So we're going to do 2x squared multiplied by 12x squared. 2x squared multiplied by negative 16x, negative 5x multiplied by 12x squared, negative 5x multiplied by negative 16x. So that's the first bracket dealt with. Move on to the second bracket. So 4x cubed multiplied by 4x, 4x cubed multiplied by negative 5, negative 8x squared multiplied by 4x, and negative 8x squared multiplied by negative 5. Once we've done that, it's time to collect like terms. One way of doing it is highlighting with colours like I'm doing it, but you can also do this kind of drawing circles and squares around different terms to help highlight it for you. So take the largest one, x to the power of 4, and we've got 2 of those. So altogether, that's going to make 40x to the power of 4. Next, we'll look at power 3. We've got negative 32. And it'd be a good idea to keep these on your calculator as you go. We've got negative 60. So take away 60 on your calculator. We've got negative 20 and negative 32. Altogether, we're getting negative 144x cubed. The last one to look at is the squared terms. And we've got 80 and 40, which is going to make 120. So our final answer is 40x to the power of 4. Take away 144x cubed plus 120x squared. So we've differentiated using the product rule. For our next product rule example, u is equal to 2x cubed minus 4x squared, and v is equal to 5x squared plus 9x. So we need to differentiate these. Differentiate u. 3 times 2 is 6, reduce the power. 2 times 4 is 8, reduce the power. Move on to v. 2 times 5 is 10, reduce the power. And 1 times 9 is 9, reduce the power. So our first step is differentiating. Our second step is substituting into the formula. So we have v, which is 5x squared plus 9x, multiplied by u dash, differential of u, which is 6x squared, minus 8x. We're going to add to that u, which is 2x cubed, minus 4x squared, multiplied by v dash, which is 10x plus 9. And this is really all there is to the product rule. So it's separating out your question into u and v, differentiating them separately, and then combining them back together using the product rule by substituting. The rest of this, the expanding the brackets, the collecting like terms, are things that you've done at GCSE. So we're going to get 4 terms per each set of double brackets. 5x squared multiplied by 6x squared is going to give us 30x to the power of 4. 5x squared multiplied by negative 8x is going to give us a negative 40x cubed. Move on to the 9x. Multiply it by 6x squared. That's going to give us 54x to the power of 3. And 9x multiplied by negative 8x is going to give us 72x squared. Moving on to the second set of brackets, 2x cubed multiplied by 10x will be 20x to the power of 4. 2x cubed multiplied by 9 will give us 18x cubed. Negative 4x squared multiplied by 10x will give us negative 40x cubed. And negative 4x squared multiplied by 9 will give us negative 36x squared. So we can collect the like terms, we can look at the 4s, look at the 3s, and look at the 2s. So look at the power of 4s first, 30 and 20 will give us 50. Then we look at the power of 3s, now we've got 4 of these, so we've got negative 40 plus 54 plus 18, take away 40. Altogether, that should give you negative 8. Then look at the squared, so we've got negative 72 and negative 36. That's going to give us negative 108. So our final answer is 50x to the power of 4. Take away 8x cubed, take away 108x squared. For our next example, u is equal to 5x squared minus 5x, and v is equal to 7x cubed plus 4x squared. So we differentiate u, give us 10x minus 5, and differentiate v, that'll give us 21x squared plus 8x. So now we just need to substitute. So we've got v multiplied by u dash, and we've got u multiplied by v dash. So now we've done the bulk of product rule, now just need to do our expanded brackets and our collecting like terms for our final answers. So 7x cubed multiplied by 10x will be 70x to the power of 4. 7x cubed multiplied by negative 5 will give us negative 35x. 4x squared multiplied by 10x will give us 40x cubed, and 4x squared multiplied by negative 5 will give us negative 20x squared. For the second set of brackets, 5x squared multiplied by 21x squared, that's going to give us 105x to the power of 4. 5x squared multiplied by 8x would give us 40x cubed. Negative 5x multiplied by 21x squared is going to give us negative 105x cubed. And negative 5x multiplied by 8x will give us negative 40x squared. So now we collect our like terms. We'll look at the power 4s, the power 3s, and the power 2s. So starting with the power of 4, that should be 175x to the power of 4. Then look at the cubes. We've got a negative 35 plus 40 plus another 40, take away 105. Altogether, that's negative 60. Then looking at the squareds will give us negative 60 as well. So our final answer is 175x to the power of 4, take away 60x cubed, take away 60x squared. So now looking at our last simple example like this, u is 9x cubed plus 8x squared. V is equal to 6x cubed plus 5x squared. So let's differentiate. U dash would be 27x squared plus 16x, and V dash is going to be 18x squared plus 10x. So now we need to substitute. So we'll write V first and multiply it by U dash. We're going to add on to that U multiplied by V dash. So now let's expand the brackets. 6x cubed multiplied by 27x squared is going to be 162x to the power of 5. Then 6x cubed multiplied by 16x is going to give us 96x to the power of 4. 5 multiplied by 27 is going to give us 135. That'll be x to the power of 4. And then 5 times 16 is going to give us 80. That'll be 80x to the power of 3. Moving on to the second set of brackets, we're going to have 19 times 18, which is 162x to the power of 5. 9 times 10 is going to give us 90, x to the power of 4. 8 times 18 is going to give us 144. That'll be x to the power of 4. And 8 times 10 is 80. That'll be x to the power of 3. So looking at which terms to collect up, we've got the power 5s, we've got the power 4s, and the power 3s. So we'll collect up the power 5s first. 162, we've got 2 of those. That's going to give us 324x to the power of 5. Next, let's look at the power 4s. We've got 96, 135, 90, and 144. Altogether, that's going to give us 465x to the power of 4. Then look at the cubes. We've got 80 and 180. That's going to give us 260x to the power of 3. So our final answer is 324x to the power of 5 plus 465x to the power of 4 plus 260x to the power of 3. Now, where the product rule is really useful is a question like this, where we have 5x squared multiplied by e to the power of 2x. Now we have a situation here where we don't have a bracket we can expand, so we can't do it that short way we looked at the start. We've got to do it the long way, we've got to use the product rule. But hopefully at this point we've practiced using the product rule on an easier question, so now something that's maybe conceptually a bit more complicated, we can do it. Now we can pick out what u and v are. It can be a little bit trickier. So we're going to take the x term, the x part of this. It's not really a term that's joined onto the e, it's all one thing. Then we're going to take the e separately as well. So we've got these two sections. So we can write that u is equal to 5x squared and v is equal to e to the power of 2x. So we differentiate these. So we have u dash, 5 times 2 is 10, reduce the power. And then remember, e is something that's a bit of a special case. When you have a line that follows the number e, then the gradient is going to be the same as a line. It doesn't really differentiate very well. So we differentiate e to the power of x, you get e to the power of x. So you differentiate e to the power of 2x. The 2 does come down like it would with any other power, but then you actually keep the 2 in the power as well. And if you're not sure about any of that, then go and watch the other videos on differentiation for these special cases. We're going to be looking at e, we're going to be looking at logs, we're going to be looking at trigonometry, sine and cos. So now differentiated, we need to substitute into the formula. So we're going to have v multiplied by u dash. So v is e to the 2x, and that's being multiplied by u dash. So we'll just use brackets to show this for the first instance. That's multiplied by 10x. Add that to u, which is 5x squared, and multiply that by v dash, which is 2 lots of e to the power of 2x. So now I'm going to multiply at the bracket. It's only one term in each. This is going to be really easy. So we do things like move the coefficient to the front. So this is going to be 10x multiplied by e to the 2x plus, this next one, 5 times 2 is 10. We've got an x squared and then e to the 2x. So trying to write the kind of the whole number kind of coefficient at the front, then the x term, and then the e term. Now we could leave the answer like that, but often with these, we can factorize as well. So we're going to kind of bring things out to factorize them. Now, there's a few options for factorizing. So for example, you could take 10x out as a factor. So divide both terms by 10x, we're going to get e to the 2x plus, we have an x left over, so x e to the 2x. Now, we've got a kind of particular aim with this, and the kind of aim here is that e is quite a complicated number. It's not very nice to work with. So we're going to try and limit how many e's we actually have. So the strategy here is it's going to be best to take e out as a factor. So we only have one lot of e. So we could take e to the 2x out, and that'll leave us with 10x plus 10x squared. Another alternative is you could factorize every single possible factorizable thing. You could take 10 out, take one of the x's out, take the e to the 2x out, and that will leave you 1 plus x. And so you're really going to think about which form of this is going to be the most useful. So again, I think just getting the e on its own, the most complicated part on its own, and only have the one version of it, that's actually going to be the easiest thing for us to write down and to work with for further steps. So let's do another example like that. So your first step is to figure out what u and v are. So u is going to be the x term, 2x to the power of 4, and v is going to be the e term, so e to the 5x. Again, I'm saying term, but they're being multiplied together, so they all do form one term actually, but we kind of see the two distinct parts, the x part of it and the e part of it. So we can say that u is equal to 2x to the power of 4, and v is equal to e to the 5x. So we need to differentiate u. 2 times 4 is 8, reduce the power by 1, and then we need to differentiate v. So we can take the 5 out as a coefficient, but then the actual e number is not going to change. So now we can substitute. So we're going to have v, which is e to the 5x, multiplied by u dash. And we can combine these two things together, but for now, just keep them separate for our substitution phase, so we don't have any confusion. U is 2x to the power of 4, and v dash is 5e to the 5x. So expand the brackets first. So we're going to have our number terms. We have 8, our x term, x cubed, and our e term, e to the 5x. Again, I'm saying term for each one of these, more I should say it's part of the term. Then for the second set of brackets, 2 times 5 is 10. We've got x to the power of 4, and then we've got e to the 5x. And again, considering that e is quite a complicated thing to work with, I'm going to bring that out as a factor and leave the rest as it is. So we're going to have 8x cubed plus 10x to the power of 4. And you might even see those two terms the other way around. Maybe the larger term goes first. It'll be 10x to the power of 4 plus 8x cubed. It doesn't matter which way around they are. You can even have it written the other way around, with the multiplication and have the e to the power of 5x at the end. And that's actually consistent with the way the question's been asked as well. So in some circumstances, that might be a better way to write it as well. But practically all these things represent the same set of numbers. Moving on to our next example. And again, we've got something that's really complicated. Now we've got an x term, so we've got 6x squared, or kind of an x segment of this. And then we've got something a bit more complicated. So we've got ln x to the power of 9. So we can write that u is going to be equal to 6x squared, which we differentiate quite easily. 6 times 6 is 12, and reduce the power. It's going to be 12x. V, more difficult, that's going to be ln of x to the power of 9. So when we differentiate that, the 9 is going to come out as a coefficient. Ln x becomes 1 over x. We can actually combine those two bits together and write it as 9 over x. So now we can substitute. So we're going to do v, ln of 9x, power of 9, and that's been multiplied by u dash, which is 12x. Adding on to that u, which is 6x squared, and multiplying it by v dash, which is 9 over x. So we need to multiply at the brackets. That's going to give us 12x multiplied by ln of x to the power of 9 plus, so we can do 6 times 9. It's going to give us 54, and that's going to be over x. But then we're also multiplying it by x squared. So we can kind of combine these x terms. Now, another way of writing 9 over x, and this will make it easier for us, is to write it as, let's make a bit of space, or we can write underneath actually, at 9x to the power of 1. Because the denominator, the x is to the power of 1, because there's no number there. So you want to bring it up to the numerator, it's going to be a negative. So if we rewrite it in this way, it's going to make our multiplication much easier. So now we can do, well, 6 times 9 is going to give us a 54. So that bit was right. But then we can multiply the powers together. We multiply x to the power together. They're going to add together. So 2 plus a negative 1 is going to be a 1. So it's going to be 54x. Now, that's a fine answer, but you might want to think about ways you could factorize it. So 12 and 54, they're both in the 6 times table. So we can take 6 out as a factor, and we can take x out as a factor. That will leave us with 2 lots of ln x to the power of 9, and it's going to leave us with a 9. 54 divided by 6 is 9. So what's the purpose of this? Well, again, the complicated bit of this is the ln to x to the power of 9. And so I want to make that a bit as simple as possible so it's easy to work with. So getting rid of the 12x from that makes it a little bit simpler. You know, say you've got 2 lots of it is a lot easier than say you've got 12x lots of it. So we're always trying to simplify the kind of more complicated maths terminology. For our next question, again, we've got a really big term, lots of things multiplied together. So we're going to split it up into manageable chunks. So we're going to have a look at the x bit, and we're going to have a look at the ln bit. We're going to do that separately. And we can do that by saying that u is equal to a 7x to the power of 4, and v is equal to ln x to the power of 7. So as usual, we need to differentiate. 7 times 4 is 28, reduce the power by 1. And for v dash, again, ln is going to differentiate to 1 over x, but the 7 is going to come down as a coefficient. You have 7 multiplied by 1 over x. That can be written as 7 over x, or it could be written as 7 lots of x to the power of negative 1. All different ways of showing the same thing. But as we know, when we substitute later, the 7x and negative 1 is going to be easier to work with. So let's do that substitution. V is ln x to the power of 7. U dash is 28x cubed. U is 7x to the power of 4. And v dash is 7x to the power of negative 1. So multiplying out the brackets, so we can write our number term first. We've got 28. Then we can write our x section, x to the power of 3, and then our ln section. Second set of brackets, 7 times 7 is 49, and a power of 4 and a power of negative 1 together is going to be a power of 3. Just add them together. Then again, you can think about bringing out factors. So 28 and 47, well, we can take 7 out of both of those, are both in the 7 times table. And look at the x terms of both x to the power of 3. So we can take x to the power of 3 out. That means if we divide by that, 28 divided by 7 is 4, but we've gotten rid of the x term from the ln x to the power of 7. We've made it simpler. So then factorising the second term, we're taking 7 out, so 49 divided by 7 is 7, and we took out the x cubed, so we've only got a 7 there. So again, we've split it up into 2 sections to make it easier to differentiate. Then we substituted into the product rule. We've expanded the brackets, and then we've tried to factorise to make the complicated bit of math as easy as possible. In this case, getting as many things away from that ln of x to the power 7 as possible. Now, moving on to the last example like this. So again, looks a lot more complicated this time, but we can split it into two sections. We've got our E section and we've got our ln section. So we're going to say that U is equal to 5e to 5x, and V is equal to ln x to the power of 4. And the whole thing here is we can't differentiate that entire term all at once. We split it into two bits. We can differentiate these two sections that we've found. So U dash, we can bring the 5 down. 5 times 5 is 25. The power stays the same for E. And for ln becomes 1 over x. We've got to bring the 4 out as well. So that's going to be 4 over x, which we can write as 4x to the minus 1. Just using our laws of indices there. So let's substitute. V is ln x to the 4, and U dash is 2 of 25 e to the 5x, plus U is 5e to the 5x, and V dash is 4x to the negative 1. So we can expand the brackets. So we're going to have the 25, we're going to have the ln term, and we're going to have the E term. Same for the second bit, 5 times 4 is 20. Then we're going to have the E term and the X term. So think about what we've done before. We've got 25 and 20, so we can take 5 out as a factor. Both terms have got E to the 5x and take that out as a factor. But then the kind of ln and the x to the minus 1, they don't really go together. So this is what we're going to be factorising. So looking at the ln part first, 25 divided by 5 is 5. We've gotten rid of the e to the 5x. With 5 ln x to the power of 4. Then we're adding to that, 20 divided by 5 is 4. We've taken out the e to the 5x, so we've just got the x to the minus 1 there. An alternate form of this is then what you could do using laws of indices is change the 4x to minus 1 back into 4 over x. So yeah, just going back to v dash, where we can see that 4 over x is the same as 4x to the minus 1.